They told me to open my mouth.
They take your fingerprints, then they swab you.
I can't remember what they said after the swab was taken. They just do what they've got to do and take you back to the cell.
I don't know, they took away my DNA then.
DNA. Deoxyribonucleic acid. We all have it. It can be found in almost every cell of the human body. DNA holds information about the way we look, our health, and our personality to an extent, and is pretty much unique to each and every one of us. Personal information about us is often stored in databases. Many go unnoticed, but one has recently been a topic of huge public debate. So what exactly is the National DNA Database? Why does it exist? And what's it used for? Let's see for ourselves as we follow the journey of DNA from cheek to court. We start at the arrest. Here, DNA samples are taken from a suspect's cheek in police custody.
When they initially come to the custody suite, they'll be brought to the desk. The details of the arrest and the offence are related to myself, the custody sergeant. I then decide if their detention is necessary, and if it is, then I authorise the detention. The civilian detention officers used in the processing area of our work within the custody suite, the taking of fingerprints, the taking of photographs, and if a person's DNA has not been taken before and is not confirmed, they will take mouth DNA samples from persons.
First of all, I'll sit them down, take their photo, and then on the computer, there's basically their personal details. So I'll ask for their, for example, height, weight, any habits they have, any tattoos, what the clothes they're wearing. I'll enter that onto the computer. Once that's done, I'll then move on to the fingerprint machine. DNA then, there's two like cotton buds called swabs. We take them out 6 times on the prisoner's cheek, same again on the next side, then into a sealed container. It then goes into a bag, which is then sealed with the prisoner details.
They're then placed into a freezer. They're taken to headquarters, to the DNA department, and from there on I believe they're either processed or they're forwarded to forensic science for inclusion on the national database.
The database holds records from DNA profiles taken from subjects and also from crime scenes. At the moment there is around about 350,000 crime scene profiles on the database, and there's about 4.86 million records from individuals. Sometimes at custody suite the information about the arrest is put onto the police national computer, and then just a small section of that information will be sent through to the DNA database. And then we'll send back to say whether that record is now held on the DNA database. So there's a two-way communication. The database is there for crime investigation. So there's profiles on the database from crime stains. So somebody has broken into a property, for example, and they've cut themselves while they're breaking in. The scenes of crime officers would go in, investigate that, and would retrieve any body fluids that have been left at the scene. What would happen then is that the laboratories would get the DNA out of that sample, and then that would be converted into a set of numbers, and the database holds that set of numbers for crime scenes. If a profile is already sitting on the database that matches the profile that's just been loaded, there should be a report going back to forces. This is my profile. There's 10 areas of DNA throughout the profile, and you'll see either 1 or 2 peaks on the graph. And what happens is that your mother will provide you with 1 peak and your father will provide you with a 2nd peak. And then the computers will work out what numbers should be allocated to each of the different bits and peaks of DNA, and it's that set of numbers that then will be submitted for loading to the DNA database. The physical database, it's not very exciting, I have to say. It's a server that holds an Oracle application, and the server is probably as big as a briefcase, and that's all it is. It's stores in a server room that's got other servers there, so you can't actually tell unless you know which server it is that houses the DNA database. We can't tell you where that is, obviously, to protect the data. The access to the database itself is very restricted. Within the UK, there are between 35 and 40 users that have got access to the database. No forces have access, no forensic laboratories have access to the database itself. And we review access each month to make sure that only the people that need to have access should have access. I think it's that misunderstanding of DNA is perceived to be the tool that cracks every case. It's not. It's just helping to guide forces in their investigation process.
DNA evidence is extremely broad. It could essentially come from anywhere. Unless it's visible, like a bloodstain or something, what we're looking for is physical items which have had some kind of contact with the perpetrator. Scenes of crime officers need to narrow down what they're going to look for, and ideally try and look for something which is likely that the accused has actually touched. Once an item of evidence has made its way into the DNA lab, let's say it's a cigarette butt, for example, that you suspect the defendant may have been in contact with at the scene. Small sections of it can be placed in a tube, and then what you do to that is add a variety of chemicals which are trying to denature and break down the cells. So we're trying to get into the DNA. We're then going to try and extract that and purify it so it's in a suitable medium to actually be analysed. Later on, you run the sample on a sequencer, which is what actually generates the profile itself. In the UK, we use a system called SGM+, which is second generation multiplex plus. And what that does is it looks at 10 specific regions within our DNA and analyses what sort of peaks we've got. Each of these 10 specific regions we inherit a peak from your mother, a peak from your father, so we should have a maximum of 2 peaks. Times that by your 10 markers, we get a series of 20 numbers for each DNA profile. The real purpose of actually securing and analysing DNA samples at a crime scene is really that high degree of probability that you get, the high match factor that you get with DNA evidence. Fingerprints are 100% unique. If you found a good fingerprint at a crime scene, you can match that and you can be a lot more conclusive. Second down from that, you've got DNA evidence, which is again just really, really strong evidence. So DNA is up there with some of the best sort of physical evidence you can collect from a scene.
Once the police have investigated a case, then they'll start compiling evidence. The Crown Prosecution Service will put a case file together, and it's after that that I get involved.
That the evidence I shall give shall be the truth, the whole truth, and nothing but the truth.
The lawyers will contact me, give me the details of the case, explain to me what the prosecution are alleging has happened, what the defendant is saying had happened. They'd also provide me with details of the scientific evidence being used by the prosecution, in particular these days quite often DNA evidence. Because it's all very well having a scientific result, but what does it mean in the context of the case? And that's largely what my job is all about, deciding what the results actually mean. I've dealt with cases involving paternity, in other words, who's the daddy. Also cases involving sort of what's called street crime, so burglaries, thefts, that sort of thing, right up to murder cases, terrorist cases.
If it's considered that someone who is a close relative of the defendant.
My job would be to look at the DNA profile obtained from the sample from the crime scene, compare that with the reference samples to see if they match. Obviously, the more bits of DNA you look at, and the more bits of DNA that match, then obviously the stronger that match is. evidentially. And we can calculate what's called a match probability, or the chance of obtaining this DNA profile at random from someone picked at random from the population. A lot of people think that DNA evidence is somehow infallible. It isn't. It's possible, for example, that you and I may share the same DNA profile. Just because there's a DNA match at a crime scene, it doesn't mean that someone has necessarily committed that crime. It may be their DNA that's left there at the crime scene. It may not be. It may be, for example, that there's a legitimate reason why their DNA is there at the scene. So it's something that the courts need to be aware of, and certainly if there is a good reason why a defendant's DNA is present at the scene, that should be brought to the attention of the courts.
This journey of DNA in the criminal justice system has nearly come to an end. We now know that we leave traces of our DNA wherever we are, whatever we do, and DNA samples can be gathered from suspects and crime scenes. From here, they are then sent to receiving laboratories where a DNA profile is created, and these profiles are stored on the National DNA Database. Should a profile from a suspect match that from a crime scene, then it's possible that the suspect may have been involved and the profile may be used as evidence in that criminal case. For the sample, the final stage of the journey is storage in laboratory freezers across the UK on behalf of the police. What about the future?
It's important that people are fully aware that the DNA sample that is taken does have potential other uses. So the fact that DNA has got so much else hidden within it makes it different from other identifiers that can be used by the police. I think it's very difficult to see how the database will evolve. I think it's important that when it does evolve, though, it's subject to thorough scrutiny. And one of the difficulties with our current database is that the laws governing it have all been sort of added on piecemeal to previous laws. So the laws that govern the use of the DNA database are dating from the early 80s, when the concept of a DNA database was completely unknown. Groups think that there should be a full parliamentary debate about this, that we should decide precisely what the DNA database is for, what it's not for, put that into statute, and then as things change over time, there can be future debates which would change or not change according to the political view at the time.
Now that we have seen the journey of DNA from cheek to court, it's clear that the DNA database can assist in solving crimes, both by clearing the innocent and in convicting the guilty. However, social and ethical issues surrounding the National DNA Database remain and will continue to be debated. If you'd like more information on the National DNA Database, please visit the following websites.